Development of cold sense display using adjustment of water flow volume. In this study, we aim for development of the thermal display system, which presents cold thermesthesia by controlling water flow volume. As a feature of the system, neither a Peltier device nor ice is used. We use water of normal temperature as the heat medium. We lower the temperature of thermal display by controlling water flow volume, without direct temperature change. We change only thermesthesia without contact sensation. We realize this system in very simple structure. We show the appearance of the thermal display system. The diameter of the tank is 240 mm and the height is 300 mm. There are water and the pump in the tank. Moreover, the thermal display is put on the tank. Water circulates in the tank. We show the structure of the system. The quantity of water in the tank is 6 liters. At first, the water in the tank is sucked up with the pump. Next, the sucked water flows into the thermal display through a hose, and the thermal display is cooled. After that, the water which passed the thermal display flows into the tank again. We can control the water flow volume by switching of the pump. We show the structure of thermal display. The thermal display consists of 3 kinds of parts. The under part is made from acrylic boards of thickness 10 mm, and bears the connection portion with the hose. The middle part is made from acrylic boards which have cut off the channel. We can constitute channels of various depth or cross-sectional areas by the thickness and the cutting models of this part. The top part is made from aluminum boards which thickness is 0.5 mm. We perceive temperature changes from this part. We performed the temperature presentation experiment, touching the arm on the thermal display. The depth of the channel in the thermal display is 3 mm, the width is 20 mm, the cross-sectional area is 60 square millimeters, and the flow velocity of the thermal display is 2 mm per second. The width of the thermal display is 28 mm, the length is 77 mm, and the area is 2,156 square millimeters. During experiment, the room temperature was 26 degrees Celsius, the water temperature was 25 degrees Celsius, and the skin temperature was 30 degrees Celsius. The cycle that turn on the pump for 5 seconds and turn off the pump for 60 seconds repeated 3 times. We show the graph expresses the result of experiment. The horizontal axis shows measuring time and the vertical axis shows measurement temperature. We measured temperature of the boundary between the thermal display and the skin by the thermocouple stuck on the surface of thermal display. About 2.1 degrees Celsius fell while 5 seconds the pump was working, and about 1.6 degrees Celsius went up while 60 seconds the pump was stopping. The subject perceived the temperature changes in this experiment. We developed the thermal display system, which presents cold thermesthesia by controlling water flow volume. We use water as the heat medium and lowered the temperature of thermal display by controlling the water flow volume. We changed only thermesthesia without contact sensation. We incorporated all of water, the pump, and the thermal display into the tank, and realized the simple cold thermesthesia system.